Hi everybody, welcome back another technical demo around the Quarkus and Springboot application. My name is Daniel O. So today I'm going to showcase how to develop reactive messaging and streaming application based on Spring and Quarkus. And in this video, I'm going to really be more focus on how to compare and what is changing, what is benefit and trace from Quarkus side rather than Springboot. But you might feel maybe you couldn't develop the same capability from Springboot, but also Quarkus. But I'm going to really be more showcase what benefit from Quarkus side as well. Let's get started. So here's a quick example to develop the reactive streaming application based on Quarkus and Springboot. So as you know, in order to utilize the reactive messaging streaming, which can exchange massive amounts of data between different applications at scale, Spring and Quarkus developer actually need to implement streaming processing application based on Apache Kafka. As you see, this architecture or topology illustrate reactive streaming topology, which shows two messaging components to integrate the Kafka cluster. The first component generated random prices that will be stored in the Kafka topic. We're gonna set it at the Kafka name. The topic name is the prices, as you see. And the second component consumes these prices from the Kafka topic and applying the conversion algorithm for the converted prices resulting are sent to an in-memory stream. The in-memory stream is consumed by web browser client using server-sent event streaming. So you might think of this a little bit simple rather than your reality application on enterprise environment, but we can run from this sample application how to produce your reactive message streaming, but also how to consume, not just from Kafka topic, but also you can dispatch the application's messaging into in-memory channel. Okay, let's get into demo how to develop this application on Springboot first. So here's my VS Code. I already generated my Springboot application. In order to save my time, I just printed my solution. So I'm going to use the latest Spring 2.5.2, and then you can find here. So we're going to use Spring WebRex to manage your reactive application, but also we need to use a cloud, Spring Cloud Streaming framework. And then the other dependency is a normal Springboot application we're going to use, like a test. And one interesting is we're going to use a test container to test the application. When you go to application configurations, so first of all, we need to specify the function name based on Spring Cloud Stream because Spring doesn't support to implement reactive messaging application by the native way. So that's why we need to use a cloud streaming framework, also Spring integration ecosystem framework. So here's a simple compilation. So you just specify how to store your messaging into Kafka, like a Kafka sync, and also how to read your messaging from Kafka topic with the compilation here. So all compilation based on Spring Cloud Stream, syntax and format. And one more thing you might understand here, we need to deserialize the messaging when you store and read it from Kafka cluster. Let's go to actual application here. So this is the Springboot application. We have a main method here. And first of all, we're gonna take a look at the price generator Java beans. So first of all, we need to define this Java bean along with the Spring function name, like a generator price, which you already specified in application properties. And this price generator actually aims to generate random prices and then return the messaging stream based on use web flux. So if you have some experience to develop reactive application based on Project Reactor or Spring Reactor, you are familiar with the Spring Flux and then multiple streaming messaging based on Spring Flux return type, and also you can define mono for just a single messaging. All right, and then as you see, there are 5-second duration to generate these random prices under 100. This is just a price unit, like a currency stuff. So we're gonna drop it to every 5 seconds, and let's go to price converter Java bean. And then first of all, we're going to define another function named price converter using compound annotation. And the one interesting here, we have to create a custom service, also known as in-memory channel. So this is the main difference between Spring and Quarkus, because the Spring doesn't support to implement the in-memory channel by native way. And that's why we created the custom service here. So when you go to in-memory channel, you can find the public constructor, and then how to publish this this messaging, save in the in-memory channel, and then how to imitate the messaging, and the when you got the complete the messaging to imitate, and also error handling here. And we need to define the compilation beans to use the custom service here. And once we define the in-memory channel with some customization, and then the converter actually return webflux return type. One thing interesting here, we have to dispatch this all streaming message to all subscriber. So using that's why we define the business logic in accept method here. And then we emitted that messaging into in-memory channel here, this in-memory channel emit value as you see. Okay, so last application V in here, the process, the RESTful API, the first is RESTful API, and then the second level is a stream. And then, so this method actually emitted the value into backend client to when client to access the result by web browser, and then we're going to use the server sent event method. Okay, so here is the how to implement Docker Compose based test containers. So there are several ways to start your Kafka cluster. As an example, you can install Kafka software on your local environment, or you can just deploy the Kafka cluster using Kubernetes cluster, or remote to some public cloud, or just simply using a Docker container. So, and also sometimes you need to spin several services with the Kafka cluster. As an example, Zookeeper to manage your Kafka cluster management. So the Docker Compose is some pretty popular method to start multiple services at the same time. So as you see, Zookeeper and the Kafka service, we're gonna start out at the same time. When you go to Docker Compose YAML file, there are two services and images, Zookeeper and Kafka. So we actually used the Kafka image from StreamG project. The StreamG is really more focused on deploy Kafka cluster on Kubernetes for more scalable environment. You can also actually any Kafka image from Docker Hub or Quay.io or Google image registry, etc. Okay, and then once you start up your container image of Kafka cluster, and then you need to create the price topic. You can use actually Kafka topic command line here, and then once you create that, and you can just make sure your prices topic is created. So let's try to change my directory. In the first step, we're gonna run the Kafka cluster on my local machine using Docker Compose command line. So Docker Compose up, and it will bring Kafka cluster and container on my local machine for the next few minutes. Okay, so it almost starts up, and then now you can see the start the Kafka cluster, and then change it another terminal window, and then just making sure the prices is already exist or not using Kafka topics command line here. And there's no topics here. So let's try to run my bash script as you already saw that. To create a topic, so this bash script try to create a new Kafka topic name prices as you see, and then we are all set to run our application. As you see, there are three partitions to store our topics. Okay, changing my directory to the right project, and then run a Springboot application using Maven command line. So Maven Springboot run. So once Springboot starts, and it actually tries to connect to Kafka cluster, because there are already generation being already activated. So price consumer, as you see, and then it will automatically try to generate the random prices every 5 seconds, and then store to in-memory channel. And lastly, that will be stored in Kafka topic. So let's try to access endpoint the presentation layer HTML page. The first price is nothing, and then every 5 seconds we're gonna see the different generated random prices here. Okay, so pretty cool. So when you go to actually the random here to generate the 5 second, I already explained here. This is your HTML static HTML file. So actually access the endpoint we define project controller in the Springboot application. So cool. So here is how it works and how we implement and develop the reactive streaming messaging application on Springboot with the Kafka cluster. So next step, I'm going to stop the Spring Boot first, and I'm going to stop the running Docker container just to make sure the Docker process is terminated here. So I'm going to do the same thing with the Quarkus. Here's my Quarkus empty project, but I just printed the just generate from scratch. So here is I'm going to using Quarkus Reactive the extension and the messaging Kafka extension, which allows me to integrate Kafka cluster and the other all dependency for CDI and JUnit test, also test containers. In the same Docker Compose YAML file and the same topic bash script. And then when you go to test directory, you can find the same Docker Compose class to run your test container for testing side. All right, the one different thing is the Quarkus application configuration property pretty much is simpler and more explicit for developer. As an example, there are two channel, outgoing and incoming. It's a pretty better readability. I mean, the developer can say, oh, the all outgoing configuration refer to something, try to sending message to some connector. As an example, here is a Samurai Kafka, which means Quarkus, the Kafka integration extension allows developer to connect to Kafka cluster. So Quarkus provides a CDI extension based on Eclipse microprofile, reactive messaging specification to build event-driven microservices, and there are streaming application. So this extension also supports Kafka connector based on the Vertex Kafka client to consume messages from and write message to Kafka. So that's why you can see there are connectors Samurai-Kafka, and then outgoing is all about to sync your message to Kafka cluster, or sometimes you can define, if you define event bus, it will store in memory event bus. And then the incoming configuration, as you see, is all about the Kafka source. So you can store your app messaging or streaming into Kafka cluster. And also, you could specify serialization and deserialization you can implement in the Springboot application. So one different thing is you don't need to use the function as we use in Springboot application from Spring Cloud Streaming. So which means Quarkus support developer to write and read the reactive messaging to Kafka cluster directly rather than bridge it to some other framework like a Spring Cloud Streaming framework. Okay, so go to process generator. Let's try to define this class as application scope. And then first step, I'm going to define the prior random the object because I'm going to generate random prices here. And then I'm going to define some public method to send this message to our Kafka cluster. So the easy way, just for Quarkus application, you just using outgoing annotation using the channel name we already specify in application configuration. So the generated price here, and then the just public method and the return type is a multi. So we are using the Flex. We are using Flux in Spring Boot, and then the Quarkus also support the same concept with the multi and uni return type for handling your messaging application. And then we just create a form to generate every 5 seconds, and then drop it into our the outgoing the channel name generated prices will be stored in the end in the Kafka topic. All right. I'm gonna import the right package here, and then the random method random the digit is on the 100. Okay, the second Java class is price converter. So specify application scope here, and the first thing we're gonna define the constant value conversion rate, the same value 0.88 we used in Springboot application, and then this converter actually read the generated prices from Kafka topic. So that's why we just use incoming annotation. Is pretty simple. And also once we convert this prices multiple conversion rate, and then we're gonna sending this message again using outgoing extension. And then we're gonna dispatch this new converted prices to all subscriber. So to do that, we just use broadcast annotation. So one very interesting here in Quarkus application for developers, they can define and process their method for incoming, outgoing, and dispatch all message to subscriber like a broadcast. So we just simple 3 annotations to make that happen in a simple here public method. Pretty simple, pretty easy, pretty good readability rather than Springboot application. So last class we need to specify here is the price resource Java class, which handle the RESTful API. The first cast mapping, we're gonna use the pass annotation in Quarkus side, the prices, and then we're gonna define the publisher for handling reactive streaming to publish the prices when you access this RESTful API, and then just specify and develop the constructor. The one interesting here, you already see the channel annotation. In a Springboot application, there's no way to use in-memory channel based on Spring Cloud streaming or just Springboot application, even Spring integration. So that's why we create a custom service to handle in-memory stream between Kafka cluster and our microservice application. But Quarkus support in-memory channel by default for developer via channel annotation. Pretty awesome. And just define the new get method with the second level RESTful API, the stream, and then produce the media type subsend event, because the Springboot also emit this subsend side for web browser by client side, and then just return prices. Pretty simple and pretty more explicit just using annotation. All right. So let's go to back the terminal and then change the right directory in the Quarkus project, and then try to run. And first of all, there's no running Docker container, and then you just click one. So when we run Springboot application, we have to run Docker Compose first to run Kafka cluster. But in Quarkus, we actually don't need to start Kafka cluster ahead of time, because when you define test container inside the Quarkus project, Quarkus automatically trigger the start test container for development mode or testing, like a Maven verify, Maven testing. Pretty awesome. So as you see here, there are Docker container automatic startup to starting your test container, which start your Kafka cluster and Zookeeper. The Quarkus application try to connect to your Kafka cluster behind the scenes, and then lastly, your Quarkus application just started with these a lot of developer productivity like live coding and continuous testing and the dev UI, etc. And try to make sure your Docker container, Kafka running on your local machine. As you see, that there are a few Docker processes still running. And we'll go back to the presentation layer in the web page. You can see the first price is nothing, and then you can find the new generated random price every 5 seconds. So 58.08 euro, and then we'll be changing like that, like 71.28 euros. So just a quick summary. So this is the way how to implement reactive messaging or reactive string application from Spring, but also Quarkus. You can I believe you can understand what is the difference between Spring versus Quarkus. Maybe you already have some experience to develop reactive application on Spring, and then you definitely feel, wow, this is really pretty convenient to develop same features, same capability in Quarkus, but also Quarkus supports in-memory channel and incoming, outgoing, processing in the same method, same class. This feature, in the end, increase developer productivity, also robust to more good quality application for your environment. Thanks for watching. Have a good rest of the day.